Protocols and extensions. Now, protocols and extensions in Swift provide a powerful way to define blueprints for methods, properties, and other requirements. They also allow you to add functionality to existing types. In this particular section, we're going to cover protocols, protocol inheritance, and extensions. Now, a protocol defines a blueprint of methods, properties, and other requirements for tasks or functionalities. Any class, structure, or enumeration can adopt to a protocol and provide an implementation. So it just gives you a basic definition, it doesn't implement stuff. So let's look at protocols first. So first, I'm going to create a protocol. I'm going to call it describable. Let's say, if I can, describable. Variable description. So this protocol, whoever implements it, or it's a rule that anybody who follows its description, it needs to have a variable description, it's string, and should have a getter method. It needs to have a function described, which is a describe function. So for example, now if I create a struct and I say this struct is person, and it does follow the protocol describable. What does this mean? That first I need to have, so it gives me help here, I can fix it. It says you need to have description string and then you need to have code for description. So other than that, I have name, which is of the type string. I have age for this person of the type int. I have my description, which has return name and age. So I'll have that there, and in the describe function I'll say print description. So I'll print this particular stuff here. I'll just put and just so that we can see it. So this is how you can create a protocol and then have other structs follow it. Now if I want to use it, I can say Alice equal to person with name Alice, you guessed it right, age 30, and I can say Alice dot describe. Now if I run it, let's say Alice and 30, which is name and age. So that's how protocols work. Now let's look at protocol inheritance. Now a protocol can inherit from one or more other protocols, adding additional requirements. So it makes it more complex, where you have a protocol which is, let's say, identifiable is one protocol, where you have an ID, so the string type, not is, d, and that has a get. And there's another protocol which is called nameable, which has a variable name that needs to be defined, string, again get. Now when I have a protocol which is a user protocol and I want to use other protocols to inherit from, I can do this. So both these, identifiable and nameable, make sure I don't misspell. So user kind of inherits from these two protocols, and user has its own age, which is of int get. Done. Now if I create a struct called as, let's say, employee, who inherits from user, I can say variable ID, I have to implement ID of the type string. I'll have to say variable name of the type string. I'll have to define age, the type int, from all three different protocols. Now if I create an employee, or which is of the particular struct, I'll have to pass ID 1 to 3, name John, age 25. Now when I print the information of this employee, I can say employee dot name has id employee dot id of age employee dot age. Now if I run this, it will say John has an ID 123 of age 25. So that's how you can have protocol inheritance along with, this is the normal inheritance, where you have a user protocol which is inheriting from identifiable and nameable. Now let's look at extensions. Now in extensions, extensions allow you to add new functionality to existing classes, structures, enumerations, or protocols. This includes adding methods, computed properties, and more. Let's look at an example where we are extending a particular type. Now we have used int before. Now if I want to write a method which extends the built-in type int, what I can do is I can say, okay, I want to create a squared property int which returns self times self. So whatever the number is, it multiplies it by itself. You can have function multiply by number, which is an int which returns back an int return. Now this will be self times number. So I've written a squared and multiply by a particular number methods. And in here I have used the wrong arrow. There you go. Now if I create let number equal to 3 and I say print, first I can say number dot squared because I've created that function. I can have number dot multiply by, let's say, 45 and run this. First it will call this, even though it's not a built-in function, because we have created a built-in property. Since we have created it here, we have created an extension of the existing types. So 3 squared is 9 and 3 times 45 is 135. I'm not sure about that, but I think it should be right since I can't do multiplication by 45. Now let's look at extending, how you can extend a protocol. So to extend a protocol, first let's create a protocol called as our favorite protocol, Greetable, which has a function inside it called as greet. Now if I want to create an extension to this, I can just say extension Greetable. Now what functionality do I want to do? I want to extend the function itself. So whoever is implementing this doesn't have to implement the function print hello. So this is helpful when someone else creates a protocol and you want to extend that particular protocol with a common function that works throughout your application. You can do this. So I can say struct friend is of the type greetable. That's all. I don't have to actually implement the functionality because the extension does implement the functionality. So I can say friend equal to friend class, and then I can say friend dot greet. So if you see, it makes your life much easier by extending a particular protocol if you're using it again and again, has similar functionality. Now let's look at some practical exercises if you want to work along with me here. So let's start with creating a protocol, defining a protocol. You can say protocol drivable, and inside that I can use speed of double, and it has a function of drive. So this is the protocol. Now this protocol I want to be adopted by a protocol in a class. So I can say class car is of the type, it follows the protocol drivable. You can say where speed double variable model string, and then I can initialize this method automatically. I don't do anything, and then as you can see there's an error because I have not implemented the drive functionality. So to do that I can say print inside here driving at whatever speed miles per hour, and once I have that I can create my car, which is car speed of, let's say, 120 miles per hour since it's a double, and it's Tesla. I can say my car dot drive. If I run this, we'll have the driving at 120 miles per hour. So we created a drivable protocol and we created a class which actually implements that, and there we go. Now let's look at extending a particular type, which is, in this case let's do string now since we already did int before, and I can say function reverse string, something that we wrote before. Now if I want to give this functionality for my entire application where it can automatically use this wherever I want, you can say return string self dot, there is a function called as reversed, I can just use that. So next I can say let original string is equal to Swift. If you remember, we did this when we learned functions, but now we are using extensions for it. Reverse string of original string is original string dot reverse string. Let's run it. So we did everything right. Reverse string of Swift is this. So that worked perfectly fine. Let's look at protocol inheritance next. I have protocol animal, and this has a name, the type string get. I have, it does speak a particular way. This is the protocol, and then we have a protocol pet which inherits from animal, and I'll say this animal has owner string get. So I have another protocol here which inherits from animal. And now if I create a class of, let's say, dog, which is a pet, which means it inherits that protocol animal automatically. I can click on this here, fix this, and it automatically adds all these things here: name, owner, function. Forgot the initialization. Let's do that. Initialization is done. We have the function speak, which means I'll say print name says woof. In this particular case, it's a dog. Now if I go ahead and create my dog object, which is of the class dog, and owner of this dog is, let's say, Alice, and name of this dog is Buddy, I can say my dog dot speak. Run this and we'll have Buddy says woof. This is how you can implement protocol extensions, protocol inheritance using that. So in this particular section we have learned how to define and adopt protocols to create blueprints for methods and properties. We've explored protocol inheritance to add additional requirements to protocols. We've also practiced using extensions to add functionality to existing types and protocols. Now, if you have any questions, do let me know. Protocols and extensions provide a flexible way to structure and extend your code. The next section will cover error handling, which is crucial for managing and responding to errors in your applications. Again, if you have questions, leave them in the comments and I'll get back to you as soon as possible.